Hello everyone. Today we're going to find the determinant of the following matrix. Got a 3 by 3 matrix, and I'm going to do this by expanding by rows or columns. There's a different method called the spaghetti method, and then I'll make another video for that. So let's go ahead and get started. So the way this method works is you're going to start by picking a row or column to work with. It does not matter which row or column you work with, just that you pick one. So I'm going to just work with that first row, and we're going to go ahead and look at our numbers. And what I want to do now is write these numbers down. And I have my row 1, 0, and 4, and I'm going to give myself some space here. Okay, and here's why this is coming up. So again, pick your row or column, write your numbers down. Now we're going to go back to that first row, and starting with 1, I'm going to go ahead and block the row and column 1 is in, and I'm going to write the remaining numbers that I have and make it into a 2 by 2 determinant. And that would be minus 10, 7, 3, and minus 8, as such. Then I'm going to move to, and that's it, I'm going to move to the next number, which is 0, and I'm going to do the same thing. I'm going to block the row and column zeros in, and then I'm going to make another 2 by 2 determinant, and I would have 9, 7, 11, minus 8, and last but not least with the 4, block the row and column, and we have 9, minus 10, 11, and 3. So just as an example here, if I had worked with the, let's say the first or the third column, let's say 4, 7, minus 8 instead, you would write a 4, a 7, and then a minus 8, and then you would go ahead and start with that first number, the 4, block the row and the column that's in, and then you would have 9, minus 10, 11, and 3, and then you would go on to the 7, you block the row and column the 7 is in, and then you would have 1, 0, 11, and 3, and finally for minus 8, you get 1, 0, 9, negative 10. All right, and then so that's how that expansion would work. So it's identical. It's just, you block different things out. Okay, so let's go ahead and continue with our selection though, and compute this. Now, when you're working, and this is very important, when you're working with a 3 by 3 matrix, there are these signs that are associated with each of the numbers 1, 0, 4. Okay. And in our case, the 1, because it's in the position of the first row, the first column, there's a plus, so we're going to put a plus next to it. The 0 here is associated with that minus, and that 4 is associated with that plus. So we go ahead and put those signs onto those numbers, okay? And that's really important. If you don't, then likely almost 99% sure you can make a mistake here. All right. And we're going to use those signs in our computation of the determinant. And how does that work? So we're going to compute these 2 by 2 determinants. And the way it works is you're going to go ahead and, starting from the upper left number, minus 10, you're going to multiply the bottom right number, minus 8, which is 80. And you'll subtract, and it's always a subtraction, the bottom left number times the upper right number. So 3 times 7, 21, times the 1 here, oops, let me clean that 21 up, times that number on the outside, which is just 1. Now, you can put the plus on there, that's perfectly fine, but it's not really needed in this case because it's just 1. Now, the great thing here is that we have a 0. And what's going to happen is that we're going to actually zero everything there. But I'm still just going to kind of compute what the computation here would look like. 9 times minus 8 is a minus 72. And then minus 11 times 7 is 77. And then finally plus 4. Nine times 3 is a 27. And then 11 times minus 10 is a negative 110. Okay. And yeah, I'm going to compute all this out. 80 minus 21 is 59 times 1, 59. I really don't care what this is, that just zeroes out. And then 27, oh, I'm sorry, this was, let me go back. Glad I actually made this mistake to showcase something. This was not 110, it was 11 times minus 10 is negative 110, so excuse me. But that often happens where you make a sign mistake there. And what happens here is that you have two negatives, so it makes a positive, 27 plus 110, okay? So you would have 59 plus 4 times 137. And if you went ahead and went through the calculations here, 137 times 4, 28 to 1, so it becomes 548. And then 548 plus 59. Oops, 548, not 549. Plus 459, 8 plus 9, 17, 1, 0, so you get 607, okay? And that would be our total there. So any method you chose, any row or column, excuse me, you would get the same answer of 607. Now, you know, are there some drawbacks to this method? Obviously, yeah, it's kind of tedious, I would say, and you got to keep track of pluses and signs. And as you can tell with that mistake that I made a second ago, yeah, it's with the negative 110. Yeah, it's easy to make mistakes here, so you got to keep track of signs. However, this is more of the universal method of figuring out determinants of other size matrices like 4x4 or 5x5, anything pretty much. This is how we go about it. The other method, other shortcuts usually only work for specific size matrices, so just keep that in mind. All right, well, thank you for your time.